parameters. So you come into modify, change parameters. What you can do here is you can set things like an M3 screw hole to be 3mm wide. And then why this is handy is because if you want to go out and change how big an M3 screw hole is later, you can just change it here and it'll change it everywhere that you've used it on the frame after that, which is pretty handy. So I just like to set up some common ones. We'll keep it simple, we'll just leave it as the M2 and M3 screw holes, and then maybe also press nuts, which I like to do 4.45mm diameter. And click OK. So now we're ready to start actually designing. So you come up to the top, click New Component, and we'll start with the bottom plate. Just name it what you want here, press OK. Now what you can do is you can click L to bring up the little origin and then click the axis you want to start sketching on. So I'm going to sketch on the bottom, so top-down view. Okay, first things first, we're going to put in our 20x20 screw holes. So I like to start with just 2 lines going out left and right. This is good for when you're changing the symmetry of your frame later on. So this will be a 3mm screw hole here, so I can just type in M3 and we see how we set that parameter earlier on. So now if I press OK, oh that's really small. If I press OK, what you'll notice is if I finish my sketch, I can come up to parameters, change that M3 value, let's just say to like 12, okay? And see how the hole got bigger? Very nice, that's helpful later on. So I always like to do that when I start designing my frame. Okay, let's put it back to 3mm and keep working. So to get back into the sketch, you just come over to the bottom plate, click on the 2 triangles till you can see the sketch, double click on it, and here we are, back in. Okay, now what we want is this hole to be 10 millimeters from each of the axes. So when we mirror it around these axes, we get like a 20x20 hole pattern. Am I going to design my own frame for racing? I've been working on a frame for quite some time, almost a year now. Hoping to release it through the Australian frame company Quad Racer / Lethal FPV in the coming months, so look out for that. Anyway, so to set the distances, we click D. Okay, click on the circle, click on the line we want it to come to, and then we set that to 10 millimeters. Then you click D again, the circle, the line, 10 mil. So now we've got a circle that's an M3 screw hole size that's 10 millimeters from each of these lines. Okay, then what else would we want? We'd want, okay, for arm mounting, how about we just do a 30x30 and 20x20 screw hole and leave it simple like that. So come up to circle, make another circle, click dimension, which is the D key, and set it to M3 once again. Okay. Now what we're going to do for this one is we're going to set it as a 30x30 screw hole. So that's 15 millimeters from each axis, just like that. Okay. So now we've got 2 screw holes for 30x30 and 20x20. You'll see when I mirror it around these 2 axes, it'll become all like nice and square. But for now, we'll just work in one like quarter. This is good because it saves you doing like, it means you do like 1/4 the work essentially versus doing this 4 times, and it's really bad to have to repeat yourself over and over. And in the bottom plate, I think that these are the only screw holes we're going to need. So now I'm going to do the outer perimeter of the frame. So because this 30x30 hole will be the outer edge of our bottom plate, what I'm going to do is I'm going to use this offset tool. Okay, click on the circle, and I'm going to offset it by, let's say, 3 mil. Okay, and then I press OK. Now what I'll do, working off this, I will just get the arc tool. I'll click once on the circle, once over here, and I'll just place this third point anywhere. So essentially what I'm going to do is I'm just going to like taper in from this perimeter over to this side and the same over here. So let me quickly do that. A really handy function we can use here is the tangent tool. So if I click tangent, the arc, and then the circle, see how it comes up and stays tangent to the circle wherever we drag it. That's super handy. And then another super handy feature is with this arc, it's essentially a section of a circle. So what we want is for it to contact this line completely perpendicular. So what we can do, well, let me do it. No, it won't. Okay, so another way to do this is just to make this line and that point and this line pretty much touch. So we can use the coincident tool up here. Click on the point, coincident to that line, and it places the center of the circle on this vertical axis, which means that now this line will contact this completely perpendicular, and then it'll be tangent to the circle here. At this point, now it's just like personal preference how thin we want to make this, but just for the sake of the video, I'll space it around 15. That should be a good number. Okay. Now what I can do is I can do a line from that 30 by 30 hole inwards, and I can actually mirror this line around it. So I'll do that again. I clicked on the line I want to mirror, create mirror, and then we select the mirror line right here and see how that just mirrored it nicely. And then this is where all the magic happens. We select everything, including all these dimensions, but we don't need these lines coming up the top. I don't know why it's still selecting them. So we can just do it manually. Okay, we select everything just like that, and then mirror along this axis. There you go. And then we select everything one more time. Just like that. And then we can go mirror along this axis. And there you go. We've got something that's starting to resemble a bottom plate. Just for ease of use, lines like these ones here, okay, that aren't like actually part of the structure, okay, and then these lines that we used for mirroring around, which also aren't part of the structure, what I like to do is highlight them all by shift clicking, and then you can press X. This makes them construction lines, which pretty much just means that they don't like count as a boundary when you're selecting zones to extrude, which is handy. It saves you from, like, I don't know, accidentally not clicking little portions. So that's that. So now that this sketch is done, I can click Finish Sketch, and we're going to extrude this to be a 2mm thick bottom plate. So I'm going to click this middle zone, and then the radiuses around the 30 by 30 mount screws. Okay, by once again shift clicking, come up to my top left and click Extrude. Then select 2mm. Okay, and there you go. That's a bottom plate. Okay, now let's start working on the arms. To make a new component for your arms, what I'm going to do is I'm going to come up to the overall component. I'm going to select that by ticking this little circle. Right click on it and then click New Component. And I'm going to name it Arms. Okay. I'm going to choose to start my arm sketch at the exact height of this bottom plate. So a way I can do this is I can click L, and instead of clicking one of these faces like I did to do the bottom plate, what I'm going to do is I'm going to click the bottom plate itself. Okay, now I'm actually sketching, and what you'll notice is I can lock my cursor to all of these screw holes and all of these edges, which makes it a lot easier to build your arm around the bottom plate. Okay, so where we're going to start is I'm actually going to start by making the tip of the arm and work my way in. So if we want a 200mm motor-to-motor diagonal distance, what we'll do is we'll go a length of 100mm from the center, then click Tab, and then set that to 45 degrees, okay? Now we've got 100mm, 45 degrees, and we can click Enter, okay? So this is essentially going to be the path our arm takes. Because this won't actually be a border of the arm, once again I'm going to make it a construction line, which is what happens when it goes dotted. And then at the very end of this is essentially the middle of our motor mounting screws. So what you'll notice on most arms is they have that little hole in the center, just in case your motor has like a screw at the bottom that hangs a bit low, it doesn't hit the carbon. So a common size I like to go is about 7.5mm. That seems to work for me. I haven't had any issues with that. Yes, X is to create the construction line. So if I click on it again, we can make it a solid line. Click on it, X again, construction line. You can also just use the button up here, which does the same thing. So click on the line, construction, not construction, so on and so forth. Okay. We're just going to go for a typical 16mm mounting pattern. So what we can do here is we can make a circle, click D to set the diameter, okay, and just make that 16. So now all our motor screws are going to lie around this circle, okay. Now I'm going to make a line going from the center out. What you'll notice is this is because the arms are perfectly 45 degrees, the motor mounting will also be like a perfect cross. But if your arms aren't perfectly 45 degrees, it's good practice to add this line. Why that's handy is because you add the line, you put the M3 motor screw hole at the end. Luckily for a 45 degree arm, this line ends up being just perfectly horizontal. But if the arm wasn't 45 degrees, so in something like a Stretch X or Squish frame, or even if your arms like don't go through the like 30x30 and 20x20 mount holes to end up being perfectly 45 degrees, what you can do is you just set an angle between the arm and the line going to the motor hole, and you set that to 45 degrees. That way you've got like your motor holes evenly spaced in relation to the direction that the arm protrudes. That'll make more sense a bit later on. And then what I can do is I can... Actually, I'm going to try something. This might make my life really easy. So I'm going to highlight the circle in this line, and I'm going to go circular pattern. I'm going to select this as the center point, and I'm going to... Oh, and I'm going to set a quantity to 4. Look at that. How handy is that? So I pretty much saved myself doing that 4 times by just using the circular pattern tool. Oopsie. I'll show you why setting this angle to 45 degrees is handy. So let's just say your arm came out in this direction. Yeah, I know, mind blown, crazy, eh? Let's say your arm came out in this direction. You'll have this screw hole really close to your arm and this one really far away. So in this case, what you'd want to do is you'd want to set the angle from this motor screw line to the center of your arm. You'd want to set that to 45 degrees. It moved the arm. Okay. Let's just... where is it? Let's just fix this line in place so we can set this properly. So we set this angle to 45 degrees, and there you go. Now, in relation to the arm, all the screw holes are evenly spaced. So that's what I was trying to say before with the 45 degree angle arm. Anyway, I can undo that. There we go. So you always keep this angle at 45 degrees, essentially. Okie dokie, moving on. How did I lock the line? So if you make any line, and you don't properly define it, you can just move it around, change its length and whatnot. If you don't want to properly define it, but you don't want it to move either, you can right click on it and click fix or unfix, and that essentially makes it green, and now you can no longer, well, you can change the length, but you can no longer like move the line around. I think length is the only control you have. Okay, now that this is done, what you'll notice is, yep, no worries. What you'll notice is there's a lot of lines in here that won't actually correspond to like edges of your carbon fiber. So things like these lines going out from the center won't have much of an effect in the final product, and also this 16mm diameter circle won't have much of a effect at the final product. So I'm going to select them all and make them construction lines. Then I'm going to set the distance from the motor hole to the edge of carbon. So I'm just going to set a circle of any diameter. Okay. Then we can use the D function, but instead of just clicking on the outside, what we're going to do is we're going to click the outside and then the inside. This allows us to specifically change the distance from the M3 screw hole to the outside edge of carbon. 3 is usually a safe amount to go. Sometimes you can go 2.5. This is kind of more judged by the thickness of your arm and how much strength you want, and how much you want to obviously be braking your arms at the motor base. But from my experience, 3mm usually works pretty well. What you'll notice is we can also use the circular pattern tool from before. With that circle, set the center point there, and then set 4. Now we've done this 4 times. Let my computer load. Okay, and then lastly, what we want to do is we want to create a nice rounded edge between each of these circles. How I like to do that is I like to go to the arc tool, which allows us to select 1 point here, 1 point here, and then we just get this 3rd point wherever we want. A good place to put it is usually on this 16mm diameter line. Okay, then I like to use the tangent tool up here. Click on the arc, click on the circle, becomes tangent. Over this side as well, click on the arc, click on the circle. Look at that, we get a nice smooth transition from the radius around one motor hole to the radius around the other. Now you just want to do the same for the other 3, well, let's just say the other 4 for now, sides. So I'll circular pattern that around the center 4 times. Done. What you'll notice is we don't really need this one because that's where the arm protrudes from, so I'm just going to delete that. But here, what you'll notice is if we highlight all this section, this is essentially the end of your arm, all done. Okay, now we're going to work on the main length and the base of the arm. Okay. So we're going to be building arms that are about 8mm wide and 5mm thick. So to do that, I'm going to click on this construction line and I'm going to click offset. If we want 8mm, we're going to offset 4 in one direction, click on the construction line again, and then offset 4 in the other direction by just doing a -4. And now what you'll notice is from this line to this line is 8mm, which is a good thickness for your arms. And then I'm just going to come all the way down to the base. Now we're going to do the mounting solution. So for the first screw hole, I like to make it a little bit wider around that screw hole than the arm is naturally. So I'm going to set a circle, and then I'm going to calculate the distance from the outside edge of the M3 hole to the outside edge of carbon, and I'm going to make this about 4mm for extra thickness, and I'm going to do the same 4mm around the 20 by 20 mounting hole. So distance from the screw hole to the outside and 4mm. Okay. One screw arm removal has become a pretty popular thing these days. So I'm gonna obviously make it so that this first 20 by 20 hole is only like a half hole, so it can slide over, and then the 30 by 30 will just be a full hole. We can start by just making this a straight line connecting the two edges. Just like that. Because I rushed it, you'll notice that it automatically made two of them tangents, but not the others. So what we can do is we can manually get the tangent tool, click that line, and like that. And now we've got a little marker saying it's tangent to the circle there and tangent to the circle there. And then it went black. When it goes black, that's when the sketch is fully defined and it can no longer be moved around without changing certain variables. See how this one isn't, it's blue, so it's not fully defined, and we can still move it around a little bit. But as soon as I get the tangent tool and make it tangent to the circle, there you go, it goes black. Okay, now for the last step of making the arm, what we're going to do is we're going to take this circle and we're going to make little lines that come out from it in this direction. So this is how the one arm screw removal is going to work. So we make both of these lines, okay, then go parallel, and we're going to click this construction line that we're working from. Now they're both parallel. Okay, maybe they're not both parallel. Oh wait, no, they're both parallel to each other. Sorry. I have to make them both parallel to the construction line individually. So I'm just going to delete that constraint. So we click on one of them, go parallel, and then to the middle line, and then do the other one separately, just like that. See, now they've gone black and they can't be moved. And this, it doesn't look too much like an arm, but after a little bit of cleaning up, it'll be a pretty nice arm. So I'm going to go finish sketch. And what of this do we actually want to extrude? Okay, so we want to obviously extrude these circles, these little edges there, the main arm, but we want to make sure to not select these little overlapping parts, because this is that circle in the center of the motor. Okay, then at the base, I'm just going to hide the bottom plate over on the left here so it disappears. And what do we want? Well, we want all of this area. We're going to want that area. Here, 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 here. And you could get caught out, but you got to make sure to click all the little white areas you want, like that. And now, that is essentially what we're going for with the arm. And we're just going to click extrude. So we're going to go 5mm thick for the arm and press OK. There you go. Obviously it looks a little bit messy at the time being, so what we're going to do, we're going to shift click these two edges here, and this is the first time we're going to use the fillet tool. So click F on your keyboard and drag this out, and let's just go 30 is a nice number actually. Let's go 20. Yep, there you go. That looks pretty safe. And then we're also going to clean up these edges. So what should we go here? 50? Yeah, 50 looks good. Okay. And then last but not least, these two sharp edges just at the very end. We're going to bring them in, let's just say 1mm. And there you go. That's a completed arm. Now all that's left to do is to mirror it in 4 directions. Okay, so we're going to click open up the arm folder, open up the bodies, highlight the one body we've made, create mirror. Over here, select the plane we want to mirror around, and we're going to select this one. Okay, that's 2 arms. Now we're going to click on the body 1 and body 2, create mirror, select the plane, this one right here. Okay, there you go. We've got 4 arms. And see how the bottom plate's kind of like white? What we can do is, if we just click this top circle, that makes all of the frame visible. And so far, that's 4 arms, a bottom plate, and let's move on to doing the mid plate, which is where things get a little bit more interesting. But see how this is already looking pretty good? Later on we might make this gap a bit wider so we can fit a 16mm battery strap in, but I'll do that at the end, just to make our lives a lot easier. Okay, so as we did for the arms, right click on the overall component, create new component, and we're going to call this mid plate. Okay. We could make a sketch at the level of the arms, but the annoying thing about that is I don't think it'll put the origin of that sketch in the center, because each of the arms are not really centered themselves. So what we can do is we can use a construction plane. Okay, if we click construction plane, click on that bottom axis, you would do only 3 holes? Well, yeah, if you want 3 holes, this is just like a basic tutorial. If you want to do only 3 holes, that's pretty easy to do. Just -1, and you can just change this edge. So instead of going to a screw hole, it just comes up right to this one. But we'll just stick with 4 for now. Anyway, so back to the mid plate. We can create a construction plane. Let's hide the arms and bottom plate so we don't accidentally click on them. We click on the bottom surface, and then we bring it up. So the arms are 5mm, plus the bottom plate is 2mm, so that's 7mm total, and press OK. Now, what we've essentially done is we've got a plane that we can sketch on that's the height of the top of the arms. Okay? Click L to start a sketch, and see how now we've got the origin planes, but also this extra one that we created. And I'm going to click on that and start a sketch. What you'll notice is when we did the arms and we did the sketch on the what's it called? We did the sketch on the bottom plate. We could actually lock our cursor to the screw holes, but since we just did a construction plane this time, we can't, so it's not letting me click on these circles in any way. A good way to get around that is to use project. So that's a tool where we click P on the keyboard, and we can just select in the center of the bottom plate, click OK. And now essentially what we've done is we've projected the sketch of our bottom plate onto our mid plate. Okay. So the only difference between our bottom plate and mid plate is that we're now going to add screw holes for our standoffs. Okay, so as we did in the bottom plate, I'm going to make some lines that we can just simply mirror around to make our life easier later on, just like that. And then our standoff hole up here, we're going to make it an M3 diameter. Okay, and then where do we want to place this? So I'm going to do it about 24mm. So the spacing between the 2 front standoffs is 24, and the spacing between the back and front ones, let's say, is 55mm. Okay, so what we do is we click D on our keyboard, click on the circle, and then click on this line. And 24, since it's only to the center line, we halve it. So that's 12. Okay. Then we're going to do any reason for 24. There's a reason for me. The standoffs that I end up using. So 24 is probably, if you're running the thin standoffs that most frames have, 24 would run a micro and a nano fine. The standoffs I use through the company that I get my stuff cut with, Quadracer, they use like standoffs that are a bit thicker at the top and bottom, which means that if I use a 24 spacing, I can only fit a nano. But if I use something like 20mm spacing, which would work on normal standoffs, you can't fit any camera. So I just bring it out to 24, just gives me a little bit more flexibility. It can really be anything. anything you want, as long as you can fit whatever cameras you want in between the centers. And then, like I said, that 55 spacing from the bottom plate, so we can click the circle, click this line, and then what's half of 55? That's 27.5, and click enter. Okay, so this is now where our standoff location would be. Now what I'm going to do is I'm just going to use that, the offset tool once again, and I'm going to offset it 3 millimeters. All the same things I did on that bottom plate to get that nice rounded edge. So I'm going to get that arc, 1 point on the circle, 1 point on the line, and place a third anywhere. Use the tangent tool to make that line tangent, just like that. Then we make this point up here coincident with the line. And then last but not least, we can move this wherever we want, okay? Because over at the standoffs you don't need quite as much structural integrity, I can actually bring it down to about like here looks good. Okay, so I'm going to set that spacing now. 24, that's pretty close to 25, so we'll just roll with 25. There you go. And then we have to do this edge. So I'm going to use the arc tool again, which I absolutely love. Click on that circle, this circle, set this last one anywhere, then once again tangent tool, arc tangent to that circle, arc tangent to that circle, and see how it locks itself in place now. Okay, now we've essentially done everything we need to. Oh, actually, I almost forgot one step. This is very important if you want to use press nuts, which I assume most people would. These holes are still only M3, so we're going to have to beef them up to be press nut size. Okay, so we use the center, the circle, click on the centers of these, and we set that parameter at the start for the press nuts. So we just type in press, and press enter, and it gives us that extra bit of room for press nuts. There we go. What you'll notice is because we used the bigger circle, the distance between the edge of the press nut hole and the edge of the carbon is no longer 3 mil. If you want to change that, that's really easy to do. You just have to make a new circle and set the diameter from the outside edge to the center of the press nut to be 3. There you go. My computer needed a sec. And then all we have to do is pretty much redo this line and this line so they are flush against here. But I'm actually not going to do that, because what we can simply do how do you... Yeah, so in terms of where the standoffs are so your camera doesn't hit the stack, this is just stuff you'll learn. I actually use models that I've made up. So if I go into my random selection and click, so we got to make sure to have the this one open, and then bring my Racer Nano model in, and I can actually place my camera wherever I want it. And I've also got a stack model. You can just like mock up those models really quickly. You don't have to put a lot of time into them, but just like make like a big cube, I guess, in the center, and then you can kind of see how big your stack is and where your standoffs need to be. The measurements I'm going with are just from like experience really, and what I know works. And I know 55 mil forward and back and 24 mil side to side works fine. I might actually post links to all of my custom made like components and stuff a bit later on in the description of this stream. But at the moment we've got the 3 mil radius here, the standoff, everything's looking good, so I'm just gonna see, we almost forgot to mirror it all. So let's go back, use that mirror tool, things we want to mirror, all this standoff stuff, and then also this 3mm radius around the press nut hole. Oh, and also the press nut lines. This is all the new stuff we added to the sketch. Then we mirror it just like that. And then we're just going to select everything once again and mirror in the other direction. So what I'm doing is I'm just shift clicking on everything to select it all without deselecting other things. And that should be everything. Mirror around here. And then voila, you've got a bit funky but functional mid plate. Now for the extrude, so we finish sketch. We just click on everything we need. Oops, I accidentally let go of shift. So this is why you got to be very careful when shift clicking, because if you let go of it for even a second, it can deselect everything you've been selecting, and that can get really annoying really quick. I did it again. You know what? Easy way to do it. Just highlight everything and deselect what you don't want. So I don't want to extrude my screw holes. Yeah, I know. Super big brain. Not. Okay, that should be all the screw holes we need. So now that they're highlighted, extrude. And we're just going to extrude 2mm, just like that. Okay, looks a bit goofy, but that's essentially a top plate what you got there. What you will notice is when I did the sketch, the reason why I didn't worry about smoothing out these corners in the sketch is because it just saves us a lot of time if we just do it after with fillets. So we can shift click on all of these edges once again. There you go. And then we click F. Let's go 8. That looks pretty fair. Now we've got all smoothed out edges, and we can click OK. So at this point, we've done our arms, we've done a bottom plate, and we've done a mid plate. And if we look at it from the top, all our screw holes are still lining up nicely, and we're ready to move on to the standoffs. Okay, so make sure you've got that top component selected, new component. Standoffs. Okay, so as I did for the arms, I'm able to do the sketch straight off that mid plate. Okay, just like that. Because obviously our standoffs are all going to be symmetrical, I can create that vertical and horizontal line. I'm just going to make them construction lines just to make my life a tad easier. Okay. And then we're just going to say the standoffs are 5mm thick, should do the trick. So 5mm just like that. Essentially, we have the 3mm center, which the screw goes through, and then 5mm outside. So that's literally done for making standoffs. We finish sketch. We extrude 25mm. Okay, we open up the standoff's body folder, and we just mirror this both directions. Oh, let's hide my previous things. So we can actually see the origin, but mirror that, and then that way. So close up our folders and open up the overall component. Show everything. And here we go. Ah, okay. I'm noticing a problem. In my mid-plate body, there's in my mid-plate folder, there's actually no bodies. And what you'll notice is when I click on the body, it's up here, separate in the separate bodies folder. So when I went to do the extrude, I must have been selecting this overall component, and that's why the body ended up here. What we can do to move this back into the mid-plate folder is we just drag this body down, 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 down over mid-plate and let go. See how this overall component now has no bodies, and in the mid-plate folder, there's our little guy. Okay, now we should be all good to move on. We've got 4 arms, a mid-plate, a bottom plate, and 4 standoffs. So let's continue. Okay, last thing we gotta do is the top plate. So as we've done for every other part, we make sure the overall component is selected, right click on it, go new component, top plate, okay, and once again, because we're working with working at the height of the tops of these standoffs, but there's not like one body, we're going to do that construction plane we did once again. Do you have to construct for top plate too? So like, do you have to change the dimensions of stuff depending on where your top plate is going to be? And how like big your standoffs are? Is that what you're trying to say? While I'm waiting for that, we know that bottom plate's 2 mil, arms are 5 mil, mid plate's 2 mil, standoffs are 25. So with a bit of math, that's 5 plus 25 is 30, so 34. Okay, so now we've got a construction plane at the height of these standoffs, and simply click L and click on that plane. Okay, so because we did the construction plane, none of these screw holes are locking. So project using the P key, we click on just the screw holes we need by shift clicking. Okay, so for the top plate, the only real things I need are the 3mm holes at the center of each of the standoffs. So okay, now they're projected. Now I'm actually going to hide everything except for the top plate, because this is all we need to work with. Okay, we're going to set that 3mm radius around the screw holes to the edge of the carbon. Computer's a bit slow, there we go. And so we don't have to keep repeating ourselves, we can just set up these lines and mirror this circle around 4 ways. There we go. This essentially just like makes sure our screw hole isn't too close to the edge of carbon so that it doesn't break or something in a crash. Okay, now pretty much I'm just going to make a really simple top plate. So I'm going to use this arc tool a lot. We could just do the arc to the center, but since we've already got this component over here, I'm just going to do it between the 2 components. Okay, so make sure they're both tangents to each other, and then we've got this measurement to change. I'm actually going to bring it in a substantial bit because it's only the top plate and you kind of want to have room for your camera to poke out the top. Oh, that seems like a pretty good length. So, oh, see how it made the distance to the center point? That's because I did the arc from one side to the other. There was no like end point in the center, which has its pros and cons. It just means we have to set the distance a little different. It's setting the distance to the center of that circle. I'm actually just going to set that to 30, and that seems like a pretty, just like by eyeballing it, that seems like a pretty decent distance. Then we can mirror this across just like that. Okay, and now all we have to do is the sides of the top plate. So because I'm absolutely in love with this arc tool, I'm just going to go from one side to the other, something like that. Make them both tangents. And then what seems like a good measurement. Oopsie, I can't move this now. Control Z, please. There we go. Okay. Let's just get the distance. Ooh, jeez, the center of that's far away. I actually like that shape, so I'm gonna leave it at 90, and that should do me pretty well. And then we just mirror this over to the other side, just like that. Now, it's not the prettiest top plate, but it's a top plate, okay? And it's something that we can work with. So we finish the sketch, click on, by shift clicking on all the parts we want to extrude, and we select 2mm. Now, we are essentially done. We just unhide all our components, go to the overall component, and would you believe it, we've got a drone racing frame that's, you know, not the best looking, but do I put holes in it to make it lighter? That is something you can do, but that's a lot more personal preference, how you want to do that. And it's really, really simple. You pretty much just add sketches to all the planes and cut it out. I won't cover that in this. Oh, actually, I've got time. I can cover it. So let's just say we do want cutouts. So in the top plate, we make sure to select the top plate, so all the changes we make stay within the top plate folder. Any rules regarding strength and stuff? It's really just what you learn over doing it a little bit. Like that 3mm radius is just something I've found works pretty well. Like 8mm wide arms by 5mm thick is just something that like a lot of frames do, so I'm pretty confident that that'll be, you know, strong enough. In terms of cutouts, what you want to try to do is you want to try to maintain as many full lengths of carbon fiber. That's easier to explain when I set an appearance on this. So before I do the cutouts, what I'm actually going to do is I'm going to make all of this actually look like carbon fiber. So I'm going to come up to the overall component and click A for appearance. It'll bring up this big menu. We go into the plastic, and where is the carbon fiber? I swear carbon fiber was in plastic. Okay, doesn't matter, we can just search for it. There we go, carbon fiber. Okay, and then we just drag this onto everything. Okay, just like that. Standoffs obviously aren't carbon fiber, so yeah, where did that go? Dope, yeah, dude. I'll just select whatever anodized aluminium I want. Let's go with red standoffs. That seems pretty cool. So that was just under the metal aluminium folder in appearance. There you go. And then you just click escape to exit out of that. Okay. What I meant by maintaining as many lengths of carbon fiber weave as possible. See on this top plate how you've got like a grid of carbon fiber weave. What you want to do is you want to try to maintain as many full uninterrupted lengths of this weave as you can. Okay. In the top plate, this is pretty simple, but in something like your mid plate, where you've got a lot of interruptions already created by holes that have to be there, it's smart to make your cutouts in line with those holes, because essentially you're just adding a cutout in an already interrupted path of carbon fiber weave, which means that non-interrupted ones get affected a lot less. Okay, so an example of that, if I go to midplate, I'll just click on the surface of the midplate. Okay, if I did a big cutout in the center here, okay, sure, you'd save a lot of weight, but you'd essentially be cutting off almost all of the weave pathways, okay, because it can't get through on the edges because of these screw holes, can't get through the center because of that big one, and once again on the edges it can't get through. So you'd be a lot smarter to make something like a slot, okay, make sure we're still looking at it from the top, something like a slot here or here, okay, because essentially now these cutouts, obviously this is just rough and I wouldn't put it this close to screw holes, but since these carbon fiber pathways are already interrupted, it's like you're not going to lose too much tensile strength by putting cutouts there. That just means that the places that have non-interrupted lengths of carbon fiber, now these can be fully like full lengths, and yeah, pretty much just like leads to a stronger plate overall. Where will I add my cutouts? I'll just stick with circles because that's nice and simple. So I'll put one circle there, one circle there, and I might do just a very, very conservative slot in the center. So just like that. So what you'll notice is all these are in really rough positions. So we can just use the D key to start setting sizes. So we can set this to let's say a 6 mil thick circle. We want to place it, you know what, let's make it 5 mil thick diameter. I want to place it somewhere around there. So using the D key. Oh, almost forgot. Got to set up these straight lines so we can actually properly set our dimensions and do proper mirroring. Make them construction lines. Okay, so we set the distance from here to there. Let's leave that at 9 mil. Seems pretty good. Here to there. Let's set that at 20. Hello? Oh my god. Okay, so why that happened was because this line here, usually it automatically is set to a horizontal line, but if it doesn't do that automatically, can I put the stack in cam in after? I sure can. See this top one, how it went black, and this one is still like blue. How we can get around that is we just click on the line and click this horizontal vertical constraint. It goes black, it's locked in, everyone's happy. Now let's set this dimension to 20 mil again, okay? That's a good hole, pretty safe, shouldn't interrupt too much carbon fiber. And then we'll make this one, so diameter of 6 seems pretty good. Its distance from the center, we'll make that 9 mil, so it doesn't get too close to the edge of carbon. And then what you'll notice is it can still move up and down. So instead of making the distance from this to the center circle 0, which I don't think works, it might work. What we can just do is the coincident tool. Click coincident, click the center of the circle in that line, and now they line up. It goes black because it's perfectly constrained. And then let's just do this slot last. Okay. Nice, yeah, buddy. This slot, Yeah, no, fusion's so good. So this, I'm gonna make this slot really, really narrow, as to not interrupt too many weaves of carbon. So I'm gonna set its width to 2.5 mil. Okay. I'm gonna set this center line. I'm gonna use the midpoint tool and then that circle, okay? So what that does is it lines up the midpoint of this center line, okay, on the center of the sketch, just like that. And then now all we can change is the height of it, and then I'm just gonna set that by clicking on the top point, the bottom point, and I'm gonna set that dimension to 10 mil. And now we could just mirror our cutouts around. So these two cutouts, we're going to mirror along that line. And then since these are in the centers, all we got to do is mirror these two around that axis. And we're done. Finish sketch. Highlight what we want to cut out of the plate. And extrude. Okay, normally extrude is to add material, but if you extrude into another sketch like that, it goes red and it turns into a cut extrude. Okay, you press OK. There you go. Now that looks pretty messy, but the point lies, like, you've got a lighter top plate. There you go, essentially. I'll leave it at that. The bottom plate's already pretty small, so I probably wouldn't want to add too many cutouts to that. So we'll leave the frame just like that for now. Pretty dope, eh? What's next? Oh, so this all looks like carbon fiber, but what you'll notice is if you highlight it all, minus the standoffs, just the carbon stuff, highlight it all, and you look at the properties, its physical material is still steel. Yeah, yeah, when you extrude, so if I redo this cutout, Fusion's got this cool thing where you can, there's a timeline down the bottom, where you can essentially go like back in time in your work. So if I go back in time before I did that extrude, okay, I can open up the sketch straight from that timeline, okay. Oopsie. Or we can just open up the sketch manually like that. If I highlight everything I want to extrude, LR FPV had a really good point. If I decide to change the thickness of this mid plate later on, okay, and I only extruded it 2 mil down, if I wanted to change this piece of carbon to 3 mil thick, the cutout won't go all the way through. So what we can select is on the right, instead of distance, we can go to object, okay, and if we select that object as the base of the carbon, okay, now no matter how thick this carbon is, it'll always cut exactly all the way through. So, good little addition there. Thank you for that. Okay, so that's most of a frame done. Okay, if we want to look at the weight that we'll get, obviously standoffs aren't carbon, so we'll get rid of that. We just want to figure out the carbon weight. Okay, what we do is we, what's the best way to do this? I think highlight everything, right click on it, and go physical material here. Okay, I think this is the menu where carbon fibers, yeah, here it is. CFRP is carbon fiber. So we just drag that onto everything, and now press escape. It doesn't look any different, but what you'll notice is when you look at the properties of everything, by just right clicking on it, now it is physical material carbon fiber and appearance carbon fiber. Okay, what that allows us to do is calculate the weight. going into properties, it says that this is 40 grams, okay? The inbuilt density of carbon fiber in Fusion I've found to be a little bit off. So a good way to combat that is I'll give you a manual way to do it. So you right click on carbon fiber, go edit, advanced, physical, and then mechanical, and I'm pretty sure it's the density, which I like to set. Wait a second, did I not go into carbon fiber? Sorry, I went into steel. Yeah, 1.6. 1.6 is Armaton. I use stuff that's 1.8, I think, but we can do whatever. So if you go edit, advanced, this time I actually went into the carbon fiber, not the steel. So it's currently set to 1.4, or if you want to use kilograms per meter, that would be 1040, or 1430, sorry. Since someone commented Armaton carbon is 1.623, we'll go with that by just changing this to 1.623, and then apply. Now we can exit out of that, press escape, and now we'll get an accurate weight measurement when we go into properties of 45 grams worth of carbon fiber. There you go. Since the carbon usually doesn't change, that's all I measure the weight of. All the hardware, I don't bother, because you can change that so drastically with what kind of hardware you use, and aluminium versus other kind of standoffs and whatnot. And oh, right, components. This will be the last thing I do, is just adding components to it all. I won't go over how to make 3D printed parts, because that's even something I'm not super good at, and it takes a lot of practice. But in terms of just about like putting parts in, so I've got a Runcam Racer Nano, which I got to put in. When you're putting it in, you got to make sure to have the overall component selected, or else the file for the component will like go into one of these subfolders, which you don't want. Okay, so I can angle it at 45 degrees and put it where I want it. A little bit up. Don't want it higher than the top plate, so that should do. Well, actually, maybe we should move it forward a tad, because that might end up colliding with the stack. So maybe there's better. Overall component selected. I can put in a stack. Give it a sec to load. Okay, there we go. Now we just gotta set the height of our stack to about right. So what's that? 9mm looks flush with the base of that. And then there's our stack. Also making these components, I might make a separate video on, because they're pretty complicated. But essentially, we're done. We've got a frame with components that we are fairly sure fit. I could have obviously made those standoffs a bit further forward. And other than that, we're done. It's up to you guys. Do you want to see me add actual hardware so you can like make sure that all the screw holes align and everything works properly? That's completely optional though, if you're interested in seeing that. How do you add screws? Okay, sure, I'll put that in. So I don't actually like to make my own screws. Thankfully, Fusion 360 has this super cool feature where you can insert from the McMaster-Carr components catalog, which is like a catalog of tons and tons and tons and tons of industry, like recognized hardware, essentially. So you go I'll redo that. So under the Insert tab, Insert McMaster Car Component, just like that. So we want to add screws and bolts. We'll use the just button head, so rounded head screws. Okay. On the left, we can, well, first of all, we want hex bits. But to sort through like an almost infinite selection of these, you go metric, which is what I like to use, M3 screws, and then let's think how long we want. So for let's start with the top plate down, okay? So the ones that go into the top of the top plate has to go through 2 mil of carbon, and then let's just say 4 mil of the standoff. So that's a 6 mil long screw. Okay, so now we've essentially got all the parameters we need. So a M3 button head hex bit screw that's 6 mil long. Okay. So aerodynamics is a big controversial topic with frame design. A lot of people think it's super beneficial, and a lot of people think it doesn't matter. A lot of the time, especially in tight tracks, having like drag on your frame isn't a bad thing. It helps you corner and stuff. There's other kind of aerodynamic features like box frames, where it's not so much like an aerodynamic shell, which allows air to blow past you easier, but it's using like fins essentially to change not how well the air passes through your frame, but like where and how that air passes through the frame by essentially channeling it. It's too complicated of a topic to go into in a video, and something that I don't feel like I'm an expert on, so I probably can't really help too much with that. I have done a lot of work on pods recently, but once again, that's probably something for another stream. Anyway, back to this. So under the 6 mil hex bit screw, I always just pick the first one. So you get this little blue number link, okay, which is essentially the parts like industry code thing. I don't know. So you click on that, okay, and then you go product details. Under product details, you go all the way down to the bottom, and it gives you a way to insert the file into your work. So I always use the 3D step file. It just goes in the nicest, and that's what works for me. So then you click save, and bada bing, bada boom, you've got a screw. So I'm just gonna move the screw clear of the frame and click OK. But now you're probably wondering, how do we get this screw to be flush with these screw holes? Okay. Can I do SFGs for the frame? SFG mounting is a very complicated thing, especially on non-box frames. So something where you've got like flat arms, but you want to have vertical side braces. That's very complicated, and like maybe something best explained just to someone individually rather than making a full video over, because this is already getting long. We're at 1 hour and 20 minutes, so let's just finish with the hardware in this video and call it a day for that. Okay, so putting the screw where we want it, what we do is we use the assemble tab. So I like to use the joint. So we click joint, make sure everything's in its current position. And what we want to do is we want to line up this flat part of the screw head to this piece of carbon, perfectly in line with that screw hole. How that's done is we select the flat part of the screw, click Control, and essentially that locks it so we can only select things like on the plane of that flat section. So I'm going to click the very center of the circle, so it's that little piece right there. I click on that, it goes like white, and then the screw hole where we want it. So we click, we drag our cursor over this flat part of the top plate, click Control, and then it only allows us to click things that are in line with the top of the top plate, and we select the center of this hole. Okay, and it does that. It puts the screw in perfectly where we want it. Sometimes it can put the screw in upside down, like that. If that ever happens, there's just a flip button over here that flips it, just like that. Okay, then you click OK. That's one screw done. Then you just click on the whole component. Oh, actually, is there an easier way? Sneak peek of my frame that I'm bringing out. I don't know. Maybe not, maybe not. I don't want too many people seeing it, but it'll be coming soon. Just be ready when it does. Okay? So see this screw body under the screw file number? I'm just going to click on that body and I'm going to mirror it. Just like that. And then you can mirror it in the other direction. Why I'm kind of like looking under the frame is because it's hard to sometimes select these planes with all the components there, but I seem to be able to do it there. Okay. Tiny peek, I'm sorry. It is really cool, yeah, I can't, I'm sorry. I've been told not to. Anyway, with these screws, now what we want to do is we want pretty much these exact same screws to be on the underside of this bottom plate. So what I'm going to do is I'm going to try to mirror this. Okay. Just like that. And then we can physically... I wonder if they'll move all together. If I joint that. No, that's not going to work. Okay, we're just going to have to do it manually, unfortunately. So I'll just take one screw. Pop it down here. And then add a joint. The center of that to the center of that. We've made mistake, fellas. We've made mistake. Okay, I think we're gonna have to skip all the mirroring and just add the components in again. Because it's not liking me doing this separately. Yeah, I'm just gonna insert them again. So in here, rounded screws, hex, metric, M3, 6mm, product details, step, save. Okay, yeah, there we go. Move it into space, create a joint, capture position, click on the flat edge, control center, flat edge, control center. And that's that, okay. Then we can finally mirror this last one. So we click that center plane, mirrored. And then, there you go. So now we've done, no worries, we're pretty much going to wrap this up in a sec anyway, so if you want to leave now, that's all good. So we've done those screws, and just to finish, we're just going to do the rest of the bottom plate ones. So a press nut usually protrudes 2mm from the top of a plate, so that's 5, 2, 2, 2. So that's 5, 6, 7, 8, 9, 10, 11 mils is how long we'd ideally like the screw to be. If I'm right, I don't think 11mm screws are made. They only make it in multiples of even numbers 2 apart. Why don't I click inches? Metric M3. And yeah, so they don't actually make 11mm screws. Luckily 10mm works. With press nuts, you don't actually have to go all the way through them to get good thread contact. So 1 mil less will work just fine. And we're just going to insert the first product it gives us. Step, save. Give my slow computer a sec to load it. Okay, and then doing this is the same as everything else. So we make a joint, capture position, click on the flat edge, control the center, flat edge, control the center. Pops it in. Okay, so you'll notice that if there was a press nut there, that would come up nicely into it. And then we mirror that across that way. Yeah, no, it's so super satisfying when the screws pop in. Where is that flat edge? There we go. Okay. And we mirror it that way. So those are the outside screws. And the last thing we're going to do is just add the stack screws. So insert component. You know what? Before we insert, I'm going to find out how high are these nuts from the base of the frame. So what we do is we go measure. Okay. We click 1 point at the bottom of the base plate, and then 1 point anywhere up here, and it'll give us a measurement. What does that say? 27 mil. Okay. So what I can do is I'm going to pick something near 27 mil for the length of my stack screw. So rounded head, hex bit, metric, M3, something around 27. Let's just go 30 mil. Yeah, that should work fine. Okay. Product details. Step folder. Save. Step file, sorry. Computer almost crashing. Okay, we good. That's a long screw. And then last but not least, we just do the joint. So flat edge, control, click on the center. Flat piece of carbon, control, click on the center. Okay. That probably protrudes a little bit longer than I'd want it, but it does the trick. And then, once again, like we've done the other times, we just mirror this around. Try to find those axes to mirror around is a bit difficult. What I could just do is just hide everything I've made. And then finding these axes is a lot easier. There you go. That's all the screws for a frame you need. There you go. Ooh, and we should just add motors to make it look fancy, eh? So click on the overall component. I've got these beautiful T-motor MCKs that I made myself. Which look amazing. Oh no. I think that screw just comes with it. I don't want that. Yeah, I'm just gonna remove that screw for now, if I can. Ooh, what you'll notice is when I insert all these things from other files, they have this like chain next to them. That means that what's in the part is dependent on another file. So if you want to make it so you can change that, you just break the link by right clicking on it. And now this gives me the flexibility to delete the screw if my computer doesn't crash. Okay, so I can just right click and remove that screw, just because we don't really need it for this. Yeah, I'll link all my parts if I find a way to do that. Okay, and then centering the motor on the arm is pretty simple once again. So we click Oh, actually, maybe it's not simple. Okay, I'll just do this an easy way. So you click on the flat edge, click on the center, and then line that up with the flat side of an arm and the center. Okay, then we rotate it till it's in line with the arm, which is just at 45 degrees because the arms are 45 degrees, and we press OK. With these T motors, what you'll notice is they've got that slight... I can't move it now. I'm just gonna... You know what? It's fine like that. Let's leave it like that. I don't want to fix it. Yeah, let's just leave it. That's fine. So, once again, we'll just mirror the motor around. Oh my god. All my factory drawings are now going everywhere. Let's delete all those canvases. And there we go, we're done. Components, frame, everything. This, honestly, would probably work as a frame, even though I did it really quickly. This would probably be a okay frame. But I'm gonna finish the video there. Hope you guys enjoyed and learnt a few things about Fusion 360. Yeah, I know, those factory drawings, when I make custom parts, I just use them to get like the side dimensions and stuff. Anyway, I'm gonna call it there. Hope you enjoyed, and I hope you guys have a great day. See ya.